Good morning, Veritas. Today is Thursday, June 18th, 2020. It's the second to last day of school, so thank you for being such great students that you're still working away with us. So nice work. Here we go for number one. You should have completed all of these assignments already. That way you can have some productive struggle and be able to see if you can really complete these independently. And then we're going to go over these answers now. Okay, so let's look at number one. Jose took 7,231 steps last week. He took the same number of steps each day. How many steps did Jose take in 3 days? Okay, so I drew a little model for this one. I drew a number line with 7 days from 0 to 7 with all equal spaces, because it says that he took the same number of steps each day, so they're all equal groups. Okay, so the number of days is on the bottom, 0 through 7. Then on the top, I put, after 7 days, he took 7,231 steps. But the question is a little different this time. It says, how many steps did Jose take in 3 days? So we need to make sure we don't just divide, because that'll be the answer for 1 day. We need to then take our answer after we divide 7,231 steps. We'll divide that by 7 days. That'll tell us how many he took each day, all equal numbers, right? Then we're going to have to take it one step further, because when we divide, our quotient will be each day, right? So that'll really represent 1 day. It's asking how many did he take in 3 days. So we're then going to have to take that number and multiply it by 3. All right, so a little bit tricky today. So we're going to do our division first. We're going to do 7,231 steps, and we're going to divide that by 7 days. Make sure we got the number of steps correct from the problem, 7,231. He took the same number each day. How many did he take in 3 days? So last week, it's telling us that it was 7 days. There's 7 days in a week. So we're not doing 7,231 divided by 3. That will just make 3 equal groups. We need to, since it was last week, we need in the same number of steps each day, we're going to divide by 7 days. Then we're going to multiply by 3. So this is pretty tricky for that reason. Okay, so if we had 7 equal groups, seven equal groups, 1, 2, 3, 4, 5, 6, 7. And if we have 7,000s, then we can put 1,000 into each group, right? So we're going to put 1,000 here. We have 7,000s and we have 7 groups. So we can put 1,000 into each of these groups. Okay, so 7,000 has been used so far. We put a 1 in the thousands place up here, because 1,000 went into each group. 1 times 7 is 7. Subtract. We have 0 thousands left because we used all 7. Now we're going to bring down the hundreds. We have 2 hundreds. If we have 2 hundreds, we can't put 100 into each group, because then these two would have 100, but none of those would. So we can put 0 hundreds into each group, right? We can't go ahead and start putting hundreds because there's only 2 of them, and we have 7 groups. So 0 times 7 is 0. We subtract. We still have 2 hundreds. Now we're going to combine the hundreds with the tens. So 2 hundreds is 20 tens. So when we combine them, it becomes 23 tens. Okay, so if we have 23 tens and we're going to break them up into 7 groups, we could put 3 tens into each group. So we could go ahead and put 3 tens, which is 30, into each of these 7 groups. Okay, so then we use 3 times 7 is 21 tens. We still have 2 tens left because we had 23 of them, and we just put 3 into each group, and 3 times 7 is 21. So we used 21 of those 10s. So we still have 2 tens that are left. We still have 20 left. Now we're going to bring down the 1, and we're going to combine it with those 20. Now we have 21. How many 1s can we put in the group? If we have 21 and we have 7 groups, we can put 3 into each group. 3 times 7 is exactly 21, so there's no remainder. So we can put 3 1s into each group. So now we have a total of 1,033, 1,030 plus 3 in each group. So 1,033 steps represents how many he took each day. So in one day, he took 1,033 steps. That means in 2 days, he took another 1,033 steps. So you could add 1,033 to that, and then take that answer and add 1,033 to that, and you'll get the right answer. So the answer is going to be about 3,000. It's going to be 3,099, but I want to show you that we're going to use multiplication to solve that. 1,033, and we're going to multiply that times 3 days. So each day, he walked 1,033 steps since he walked the same number of steps each day in the week. Now we want to know how many did he take after 3 days. So we're going to multiply 1,033 each day times 3 days. So we're going to start here. We're going to multiply 3 times 3 ones is 9 ones. 3 times 3, we're going to do 9 again. But notice it's 30 times 3, which makes 90. So we're in good shape. So 3 times 3 was 9. 3 times 3 was 9. 3 times 0 is 0. And 3 times 1 is 3. So the answer is 3,099 steps. And that is the final answer to this problem. Jose took 3,099 steps in 3 days. Okay, so the hard part about that was we had to divide and find out how many he took in 1 day. And then really, really carefully go back to the problem and say how many did he take in 3 days, and we had to multiply each day times 3 days. So the answer was 3,099. If you got 3,099, give yourself some snaps. Nice work. Okay, let's go down to number 2. It says to evaluate 365 times 52. So here's just a pretty simple multiplication problem. There's 365 days in a year. I don't know. You would probably have to do something like this sometimes, but we're going to multiply 365 times 52. It doesn't have any word problem involved. It just wants to see if we can do this multiplication. All right? So this should be a piece of cake for us. We're going to start in the ones place in the bottom right-hand corner. We're going to ignore the 50 right now. We're just doing 365 times 2. Okay, so it should be 720. 365 times 2 is 720. So we're going to do this math. 2 times 5 is 10. Put the 0. Carry the 1. 2 times 6 is 12, plus 1 is 13. Two times 360 times 2 is 720, so 365 times 2 is 730. Oops. 2 times 3 is 6, plus 1 is 7. So our first partial product is 730. We just did 365 times 2, which is 730. Okay, I was thinking about spins when you do a 360. If you do 2 360s, if you do 2 complete spins, like on a skateboard or something, they call that a 720, but it was 365, so then we had to have 365 times 2, which is actually 730. All right, so then we put our 0 here to hold our ones place. I put my smiley face, like always, to kind of remind me that I just have to put it there. I've been doing that since I was in 5th grade. We're finished with the 2. Now we're doing 50 times 365. So we got to put that 0 there to hold the ones place. Because now we're just going to do 5 times 5 is 25. You write the 5, carry the 2. But this is really 50 times 5, which is 250. See how we put the 50 and carried the 200? So then 5 times 6 is 30, plus 2 is 32. Carry the 30 over to the thousands. And 5 times 3 is 15, plus 3 is 18. And now be careful, there's nowhere else to go here. There are no more numbers to multiply, so we're just going to write 18 like that. But be really careful that there's no thousands here and there's no 10,000s here. So just be careful when you're adding those 2 partial products. It should be 730 plus 18,250. So now we're going to have 0 plus 0 is 0, 5 plus 3 is 8, 7 plus 2 is 9, 8 plus 0, and 1 plus 0. The product is 18,980. So if you didn't get that, try to look at my work here. Go back and watch this part of the video. Look at your partial products. Do you have 730 plus 18,250? If you don't, if you have a different digit anywhere here, I want you to look and see where did you make your mistake. Was it a multiplication fact that you mixed up? Did you forget to put the 0? Did you add incorrectly? What did you do to make that mistake? That is your job right now, okay? But the answer to number 2 is 18,980. Give yourself some snaps if you got that. Nice work. Last problem. Find the sum of 5 5/8 and 4 14/24. So I'm going to make some space here. Working on number 3. We're going to find the sum. So the sum is the answer to an addition problem. So we're going to add 5 5/8 plus 4 14/24. Make sure you have those numbers right. 5 5/8, 4 14/24. 5 5/8, 4 14/24. We're finding the sum, so we're adding. All right. So let's see. We're adding these, so we need to have the same denominator in order to add these fractions. So we're going to take the smaller one of 8, and we're going to turn that into 24. Because 8 can multiply to get to 24, then they'll both have the same denominator. So we need 8 to get to 24. So what did we multiply 8 by to get to 24? We multiplied it by 3. So we have to multiply the numerator times the same number. So we're going to multiply 5 times 3, which is 15. That way, all we did was multiply 5/8 times 3/3. And since 3/3 is equal to 1, all we did was multiply 5/8 times 1, and it gives us an equivalent fraction. It looks different, but it's equivalent. It's the exact same value. All right? So now we have the same denominator. Now we can add them. So now we can do 15/24 plus 14/24. So 24ths plus 24ths, the denominator is going to stay the same. That's just telling us how many pieces are in each whole. So it's still going to be 24. We're not going to add 24 plus 24. Once they're the same, we're going to keep them the same because now we have the same size pieces. So let's add those numerators together. 15 plus 14 is 29. So the fractional part is 29/24. Then we have to do the whole numbers. 5 plus 4 is 9. Okay, so we're not done yet because 9 plus 29/24, we're going to have to turn this is an improper fraction. It's a fraction that's greater than 1. So it's really going to be more like 10 and something, right? There's going to be a whole nother 1 added since this fraction of 29/24 is greater than 1. So we're going to divide 29 divided by 24. Okay, because we've learned that fractions are division. 29 divided by 24. So 24 goes into 29 one time. Okay, if we had 29 or something and we have 24 equal groups, we can only put 1 into each of those 24 equal groups. Because if we put 2, we don't have enough. We only have 29 to split up into 24 groups. So we can only put 1 into each group. Subtract, we have a remainder of 5. So we've done this a lot where the remainder becomes the numerator and the divisor, the number we divided by, becomes the denominator because we're just taking basically this remainder and we're splitting it up into 24 equal groups. That way each of those groups will get a fraction. Okay, so it's 1 5/24 when we divided 29/24. Okay. Ask your teacher for help with that and they can show you a model. I just don't think we have time in this video right now because 24ths going to take me a while to draw, but 29/24 is 1 5/24. So then when we add 9 plus 1 5/24, we have 10 5/24. Last step would be to look and see, can we simplify this fraction? Can we divide those both by 5 to simplify them or by any other number? And the answer is no. So that is our final answer, 10 5/24. I do think I should show you why 1 5/24 and 29/24 are the same thing. So I'm going to go back and do that. But this is the final answer, 10 5/24. Okay, if you had 29/24, figure that 24/24 is going to make, let's see, how can I do this? I can do, if I'm making 24, I can put 4 this way and 6 this way. Okay, so I got 24 equal pieces in there. So 24/24, we have 29/24, but this is 24/24. If we had one whole, we have 24 out of 24 total pieces in the whole colored in. So there's 24/24, but we had 29/24. So we had all of that 1, plus we had we're going to cut this into 24ths. So now this one, I cut it 4 times this way and 6 times this way. So we have 24 little pieces. So there's 24 24ths, and then 25, 26, 27, 28, 29, which makes a total of, this is 5 24ths, and this is 24 24ths, which is 1. So it's the same thing. When we count up all the 24ths, and we have 24 plus 5 makes 29 24ths here, right? If you look at all the 24ths that we have here, there are 29 24ths. And it's the same thing as having 1 whole and 5 24ths. So these are the same thing. All we did was divide to do it. But that's another strategy if you're not quite sure with your division stuff. Okay, but the final answer to this problem is 10 and 5 24ths. Give yourself some snaps if you got that. Nice job, and that's it. Have a great day, guys. See you later.